Hello, my name is Dr. David James and I'm an academic here at Sheffield Hallam University. I work in the Centre for Sports Engineering Research and we're a world-leading centre for researching all the sorts of bits of technology that we use in the world of sport to try to enhance an athlete's performance. And we work with lots of different people, lots of big companies, governments, organisations and national governing bodies and athletes indeed. And I guess what we're trying to do is we're trying to use all the best sort of cutting edge techniques from the world of engineering to try to push the boundaries of what an athlete can do. I guess a couple of good examples might be to think about the world of golf, how technology has driven the whole golf industry. And we look at things like the biomechanics of how a golfer swings the club. We look at the materials involved in the club, and even the impact between the ball and the club head. And it's all about trying to enhance that athlete's performance, trying to get a few more yards on their drive. I guess other good examples would be, say, from the world of winter sport, say sports like skeleton bobsled, where athletes are hurtling down these tracks at very high speed, and the differences between gold and silver could be hundredths of seconds. And if you can enhance that whole system just a little bit by, for instance, maybe looking at the aerodynamics of the slider or the friction between the runners and the ice to enhance that aerodynamic capacity, trying to reduce that drag and ultimately provide a little bit of a performance boost to the athlete. And of course, we've had some fantastic successes recently with athletes such as Amy Williams winning a gold medal in Vancouver. A good example of sport that's really been dramatically changed by technology is tennis. Within living memory, tennis rackets used to look like this. And I remember when I was growing up, tennis players at John McEnroe playing tennis with wooden tennis rackets like this one here. And the wooden tennis racket would have quite a small head, made out of wood, have just a single shaft. And of course, rackets today look very different. For starters, they're a lot larger, they have a larger head, and they're much lighter. Now, this is a key engineering development. And I guess to understand why these oversized rackets became so popular, we have to understand some of the fundamental principles of really how the ball hits the racket and some of the fundamental physics of the game. One of the key things is that they're actually, I guess you might say, they're more stable. For most of us, when we play tennis, when the ball hits the racket, it doesn't actually necessarily hit bang in the center. It will tend to hit sort of slightly up or slightly down. And of course, what will happen is that racket will then rotate during the impact. And if it rotates quite a lot, the ball will go off in the wrong direction, and you effectively run the risk of losing the point. But the key thing of these large rackets is that because they're so wide, they have this property, they have what we call a high moment of inertia, which means that they rotate quite slowly. And that's very useful because it means you can play the off-center shot, the racket won't rotate very much, and the ball will go roughly in the direction that you want it to. I guess the other side of that is with the narrow rackets, the opposite happens. And the narrow racket will twist very quickly in your hand because it has a low moment of inertia. So it twists very quickly, and the ball will tend to bounce off in a direction where you didn't really intend it to. So in effect, the larger racket made the game more, it allowed intermediate players to have greater stability, and I think that probably made the game a lot more accessible. And there are lots of other reasons as well why these rackets became popular. For instance, the fact that you've got a larger string bed actually means that the strings can deform more, and that leads to a more efficient impact, which means the ball will leave the racket faster. So all these things sort of add up together, and effectively they've really quite dramatically changed the game of tennis. They made it a lot faster. But for most intermediate players, they've probably made it more accessible as well. So it's really changed the sport quite dramatically. And we've been working in the area for a long time. We've been working for people like the International Tennis Federation for a long time, and we've been also working directly with companies like Prince, and we've been using the latest sort of engineering tools, things like finite element analysis, to create very complicated impact models of between the ball and the racket, modelling the friction of the strings on each other. And what it allows us to do is it allows us to really create tools which we can really sort of just subtly tweak, for instance, the material properties or subtle change in the geometry to see how that might affect the game. And that's really sort of at the cutting edge of sports engineering. So if you're interested in sports engineering and want to start to try to work in this area, a really good way to get involved is to come and study for a master's programme with us here at Sheffield Hallam University. We offer the only master's programme in the UK in sports engineering and one of the only master's programmes in sports engineering in the world. Essentially the idea is that we take graduate engineers or physicists, mathematicians, people with that sort of physical science understanding, and then we give them a year of sports engineering. So you'd come, study with us, join our research centre, learn about things like human physiology, biomechanics, and of course applied sports engineering. You'd also get very involved in research and work on a live research project with perhaps a major industrial partner. And I guess the idea of that is to give you the real sort of first-hand experience of how that works in real life. And of course to give you great contacts so that you can go and get a job or even continue on with further study. And previous students have gone on to do really great things, going and getting good jobs in innovation teams with big companies like Adidas or Prince, or indeed even stayed on to do PhDs as well. So there's a really good opportunity for high achieving graduates to really get ahead there. So if you're interested, please do have a look at our website.